everything we've been dealing with so far has just been with the individual atoms. But atoms bond, or another way of saying it is they stick together. Because if atoms didn't stick together, then we'd all be essentially just a collection of atoms, and this video wouldn't be being produced. So atoms stick together and they form molecules. You take a bunch of atoms together and they'll stick together, and they'll form molecules, and then obviously molecules start building up and you get other structures. And if we started talking about organic chemistry, you'd have a bunch of atoms, a lot of carbons and hydrogens and other things fitting together, and they'd be forming proteins, and then proteins would fit together to form organic structures, and you fit enough of those together and you'll eventually get someone recording a YouTube video. So this is where it all starts. Atoms bond, or they stick together. And the purpose of this video is to just kind of think about the different types of ways that an atom can stick to another atom. So the first and kind of the most powerful way, or I think of it as the most powerful way, is if you take an atom that really wants to give an electron, so really wants to give, and then you have another electron or another atom that really wants to take an electron, wants to take, right? And we've talked about this before. An atom that wants to give an electron wants to give it because it's trying to get into kind of a stable configuration in its outer shell. Everyone wants to look like a noble gases. They're all envious of the noble gases because the noble gases have 8 electrons in their outer shell. So who wants to give? Well, if you look at the periodic table, the people who want to give really badly, and we've talked about this a good bit, are the alkali metals. These guys just really want to offload an electron. And there are other people who want to give them, but let's take the extreme example. So these guys really want to offload an electron. And who wants to take an electron? Well, the halogens, we've talked about these. These guys love taking electrons. They're not the only ones, but they are some of the most they have a very high electronegativity. They really want to take electrons. So if you put these around each other, what happens? Let's say, I don't know, let me make a sodium and chlorine. Sodium, let's say we wanted to flavor some of our food. Sodium, so you have some sodium and you have some chlorine. So sodium, let me draw its valence shell. Sodium's valence shell looks like this. It's got 1 electron sitting there that it would really just like to get rid of. And then chlorine looks like this. Chlorine, it has 7 valence electrons. 1, 2, 3, 4, 5, 6, 7. So what happens is this guy wants to escape. This little blue electron right here really wants to escape the sodium and essentially move into the chlorine. And obviously it's not like a 1-for-1. You have billions and trillions of these atoms rolling around, and these electrons jump off and they go to one, then they jump to another. But for the sake of our purposes, let's say we just have these 2 atoms. And what you have is that electron jumps off, and then if that electron jumps off, what happens to sodium? Well, then the sodium has no electrons in its valence shell, although it does. Now its valence shell is 1 lower, but we could say it's lost that 1 electron that was out there. And now its atomic configuration will look a lot like neon, right? Sodium, you lose an electron. Now it looks a lot like neon, at least its electron configuration. But now it has 1 fewer electrons than protons. So now it has a positive charge. It was neutral back here, right? Now it's positive. And now, what does a chlorine look like? And I'm kind of mixing up notations, but that's really just to give you the idea. So chlorine before had 7 electrons. 1, 2, 3, 4, 5, 6, 7. That electron had jumped onto the chlorine. So now it's happy. It looks a lot like argon now. It has a completely filled valence shell. And what's the charge now? Well, it has 1 more. Now it'll have 18 electrons instead of 17, right? So what is its charge now? It has 17 protons, 18 electrons. It has a -1 charge. So I'll just put a negative up there. And it has a negative charge now because it got that electron from sodium. So now these guys are both happy from an electron configuration point of view. They both have these stable valence shells, but they're attracted to each other. Right? Coulomb forces. Positive is attracted to negative, negative is attracted to positive, and it can be very strong, this electrostatic force, so they stick to each other. And so this force of attraction, this is an ionic bond. So when they'll form NaCl, And this bond, they're not sharing electrons. This guy wanted the electron so badly, and this guy wanted to give them away so badly, he just handed the electron over, but he says, oh, by the way, now that I handed you the electron, you're negative, I'm positive, I want to stick to you. And then we formed table salt, and we're ready to season our food. Now that's the situation where one guy really wants to offload electron, one guy really wants to take it. What happens in the situation where they're both, they're both a little bit more, they're not as extreme in their views in how whether or not they want to give or take electrons. So let's think of a few other examples. The best example is what if elemental oxygen, right? Let's see, elemental oxygen. So this right here, this is an ionic bond. And not to jump back and forth, but I'm not sure if I just mentioned that. Why is it called an ionic bond? Because we formed ions. When we donated the electron from sodium to chlorine, we formed an ion. The sodium, this became a cation because it's positive, cation, and this became an anion because it's negative. And then they stuck to each other, so this is an ionic bond. Ionic. Fair enough.